So thank you very much. We will start today the new dialogue, which is on data preservation. And you know now the idea of these dialogues, but we will change a little bit the usage and ask you to all put your camera on to make sure that we identify all the participants. You have seen that the process has changed a little bit. Thank you. Bente, you can take a snapshot at the same time.
I've done it.
So we had some security problem last week, so this is why now we will ask everyone to put the camera on the start, and we go through this registration process. This is the challenge to be open and at the same time secure. So we apologize for the inconvenience, but this is how it is. I will share my screen to begin the introduction of this dialogue. So welcome to the GEO Data Sharing and Data Management Principles Dialogue Series. And this is the dialogue which is about data preservation principles. So please, some house rules. Please, if you are not speaking, mute your microphone. If you want to intervene, raise your hand and the reactions, and wait for the moderator to give you the floor, and enjoy the dialogue series. So what is the dialogue series? First, we want to advocate the GEO data sharing and data management principles, because we could see that some people know about them, but knowing about is not like understanding and knowing them all. Some people just know the first ones and not the last ones. Preservation and curation are data management principles which are not always implemented. Then we want to raise the awareness because we want to mainstream. We know that many pioneers already know them, but we want to mainstream these principles and this knowledge, because we need to have more sustainable data access. And why? Why now? Because we know that the space data providers know very well these principles, but this is not always the case for in situ. And in situ is becoming more and more important with the climate change challenges and all the decisions we have to face now. These dialogues will be recorded. They will be published on the GEO website, and they will be made available for publication to other communities. They will also be available through YouTube. Later on, when Chris will introduce the first principles, I will put into the chat the link on the Knowledge Hub where the first dialogues have already been published. So what we want to do is really to provide perspective and the structure of these principles, and also mention as much as we can in each dialogue, see the perspective on in situ, but also talk about law and policy, because we have seen that licensing is also something which is very important to access the data and develop the EO market. And the GEO work program examples are here to show you. After a generic presentation, theoretical presentation, we invite some people implementing these principles in the GEO work program to make these principles more, I would say, more applied, and show you how this can apply to your work. So this is the roadmap we had for this dialogue. So you can see that today we are on this one about preservation. Next week will be about curation, and we will probably, before the 24th of October, offer you a possibility to go again through the usability, which have been disturbed by some hacking last week. These things happen to everyone, I think. And this time, unfortunately, it was to us. On the 24th of October, we will have a special one on the data management self-assessment tool, which have been developed in the context of eShape and made available to the GEO community. So the data sharing principles, they have been presented into the second dialogue, but it's always important to go again through these principles, because we want to encourage data sharing. It's so important now to develop this EO market and enable the community to build on EO data. These are the 10 principles we are going through. So these are on the left, the ones which have been presented. As said before, the usability we will retrieve and go further in the next days or weeks, in the next weeks for sure. So please stay tuned on Twitter. We will inform about this exceptional dialogue. Today, we will focus on these two principles: preservation, which is the DMP7, to protect and preserve the data for future use, and DMP8, to associate metadata held in the data management, but I will not go into the detail because Chris will do that much better than I can do. So I am myself Marie-Françoise Boidreau. I'm a Europe Director with the Innovation Program of OGC, the Open Geospatial Consortium, and we have a focus on I have a focus on initiatives related to Earth observation. OGC does much more than that, but my focus is this one. I'm involved in GEO in the program board and in several GEO's working groups since the last 5 or 6 years. I was working before with the French Weather Service, Météo France. And I'm co-organizing these dialogues with Bente Liliaby, who has been involved in the GEO community since 2004. And as you can see, she had a lot of responsibilities from the research mapping agency of the Norwegian mapping agency, but she has also been engaged with GEO since many years and part of the GEO program board. And now she runs a small research and consistency company, BLB, and she's still involved very much with the GEO. Of course, we do not do that only by ourselves. We have the support from the GEO Data Working Group, which is led by Chris, who will introduce today the principles we want to focus on. If you want to make any question, if you want to make any comment, please use the Zoom chat. We will also have some Zoom poll to engage with the audience, where we will ask your position and your answers on some questions which are of interest and relating to the talks. So today, data preservation, about preservation and verification. I have already introduced the dialogue series, and now I will let the floor to Chris Schuber from the University of Vienna. And Chris Schuber is leading, as said before, the data sharing and data management subgroup since 2020. As you can see, he has been heavily involved in standardization via Inspire, and especially focusing on data modeling and EU vocabulary management. And in Austria, is responsible for setting up the climate research data infrastructure. This is why data preservation, of course, is familiar to him too. Chris, I let you the floor.
Thank you, Marie-Françoise. Yeah, thanks again. So yeah, we will start today to describe or to talk about two data management or geodata management principles on data preservation and data and metadata verification. So they are collected in the category of preservation. So, and as you all know, and there's a rapidly increasing volume on information which exists in a digital form, and losing data in general could not, or isn't not an option at all, and could not be an option for data repositories, data provider, and so on. So data and data fragments which are provided may be reused immediately, or also years later, or and have to be available over a certain time span. So it's it should be also or data should be also accessible after a certain point of time. So, and we have to be sure regarding security and trustful repositories, but also data formats and so on. I will go or describe it a little bit later now. So data preservation in general, it's a challenge, and it's also, if you implement this, it's a day-to-day business, and yeah, data preservation is challenging, troublesome, and we need or there's a need for guidance. So, and one aspect is here the definition on the data principles. So data will be protected from loss and preserved for future use. Preservation planning will be for the long term and include the guidelines for loss prevention, retention schedules, and disposal or transfer procedures. The second, and this is more a technical challenge, data and associated metadata held in data management system or in data repositories will be or has to be periodically verified to ensure the data integrity and authenticity and readability for reuse. So I will describe a little bit the content or the surrounding on the DMP 7 on data preservation. So the data preservation of data in a digital format requires certain actions which has to be applied and also to be performed. So it is an important aspect that the data provider is planning this process on preservation. So it's yes, also scheduled, or it's important to schedule the transformation of a file type to avoid the obsolescence of outcoming data formats, and it covers also the backup system or hardware system, recovery plans for the possibility if systems fails, systems or data are corrupt. And the plans for for the asset transfer, so for migration from one system to another system, is also important and has to be a part of the preservation planning. These details here we described in the geodata management principal guidelines are based on the OI's model, the Open Archival Information System model here. So it's was developed in or published in 2012 from the Committee for Data Space for Space on Data Systems. So just for a short explanation, also the open or the word open here doesn't mean that all information or all data are open available. So this model were developed in an open consultancy and an open forum at all. So, and it has contains a very basic conformance or requirement classes here to provide and to have this to create this preservation planning just as a requirement, but also planning for repository systems. And one example here, or one aspect or requirement here, is also to set up a trustworthy digital repository. We described it a little bit, so that what is the function of a trustworthy digital repository. So in the end, it's an explicit, or it has to be an explicit mission to provide access and to preserve data in general. It has to be also a continuity plan from ensuring an ongoing ongoing access and the preservation of the content over a time range and over a time range. So a part of this trustworthy explanation is also that you define dedicated responsibility for long-term preservation, which is planned and well documented, and it enables reuse of data over the time, especially for appropriate metadata, data formats, and data services. So, we have also some described requirements here, so that data contributed to the GEOS data portal should be reserved for long term and protected from loss for future reuse, and by a trustworthy digital repository. One example is here the Core Trust Seal certification. So I put some aspects here. So at the moment, in the status until 2022. So we have here 16 aspects, 16 criteria are listed here. So it starts from the organizational infrastructure towards a digital object management, and of course the technology, so the technology infrastructure, security aspects, and so on. The next the second data management principle, and please remember, so it's defined as data and associated metadata held in the data management systems will be verified and be maintained. So the scope and the purpose of this is really that the content has to be checked in a stable service, in a stable period, and also if it's necessary, it should be also transformed. We call it here as a file migration of data, so to ensure that data are accessible and reusable and readable, of course. So there's a constant maintenance as a kind of guarantee for the preserved data. So it's important to have this to ensure the long-term data integrity. So it's about the maintenance and file format, the authenticity, also regarding file corruption, manipulation, and readability here. So from the technical aspect, we have also to cover the architecture of hardware equipment. So it's about the location of storage and to set up redundant storage, probably also the decision or to decide if you have a hot or cold storage more for backup and long-term data which are available or should be available. So, and it's also the process of the verification. which should like as a kind of technical routine and technical testing, that data are resolvability, with persistent identifier, important for the readability and data provenance. Techniques are here, simple techniques are here. It's a like a checksum. You can apply. And the guidance here is in the implementation and or the DMPs a data management principle here provide a guidance on implementation, which also introduce the metrics how to measure this level of compliance in the end. And I put just some examples here. So the media or the data should be readable, accessibility via testing frameworks. It has also a sentence or the archive content integrity should be checked, and the data which is reused itself, it has to be also underlined or run this content integrity checks. The discussion in especially for the research sector, so the data preservation is an challenging task and effort, but it's also cost intensive. But in the end, it's important. And here I put just 2 examples here. So, and we it's important for the data life cycle, for data life cycle, which has to be implemented, and preservation is really a strong task here. This is an example of the Digital Curation Center. And regarding data quality, I put here from a current publication also the preservation, the importance of preservation processes to ensure the data quality aspects. With that, I'm finished, and say thank you.
Well,
and hope for discussion.
Thank you very much, Chris. When we announce these dialogues, we also say that we will make the connection with the FAIR principles, with the trust principles, the core principles. And it is obvious that these preservation 2 principles are very connected to the trust principles, which are about making reliable repositories and trustable with security, with hardware equipment to make redundancy and make sure that the data is always accessible. Of course, the FAIR principle, we can see the relation with the R of reusability, which is very clear, but not only, also findable and accessible is also related. And then you have identified some points which are very important to distinguish from the other principles with the cost, which is attached to the preservation. Because the other principles are more related to the development. There is a cost which is usually clearly identified. For the data preservation, the cost is more difficult, and it needs some support because it's difficult for one organization to support the preservation on the long term. So these are very interesting topics related to preservation.
Yeah.
I think, yeah, please.
Just a word, a comment also to a kind of a migration exercise is also important from one repository, and we know it by heart. So the existence of local repositories is not really promised of our long-term availability, but migration is a really important part to provide these exercise more on the technical thing. So if the data are able really, or if the data content will be the same if you move or migrate the data to another repository.
This was also clear with your last slides, with all these documents over furniture. You have to convert from paper to digital repositories, and of course this migration is also a hard task. So the results of the poll that help us understand better the audience compared to the question today, to the issue today. Are you involved in data preservation activities? We have 27% considering to start data preservation, 18, and using historical data, 27%, and none of these 27%. So a good balance, but a lot of people interested by the topic today. So I will share my screen. Are there any questions or in the chat maybe for Chris at this stage? No, okay. So I will share my screen to introduce the next speaker.
Marie-Françoise, just to say that in the chat, I posted this slide deck that you used for introduction, so that people can get a reminder of all the data sharing principles and the data management principles, and also these slides where you get a bio that of each of the speakers. So you have that in the chat, and also you, Marie-Françoise, you provided a link to the recorded material from previous dialogues.
Yes, exactly. So the next speaker will be Noura Djibo. Noura Djibo is Secretary General, African Climate Change Research Center, and is the United Nations design contact point on climate change for 12 years from 2010 to present. He founded the African Climate Change Research Center, ACREC. So you can, and you can read about his bio. So of course, when we talk about data preservation, we all have in mind the climate change impacts. And this is why we thought that Noura Djibo could be a perfect speaker here to introduce these challenges, which are so much, which make the data preservation so important. I stop sharing and I let you the floor, Noura.
Okay, many thanks. Let me quickly share my screen. So many thanks for giving me the floor to share ideas about data preservation and analysis and management. I will look at it from a more practical point of view. So because everything that we do under GEO are basically online, but I want to come down to practical application. So the topic I am going to present is Africa Regional Climate Data Analysis and Preservation, a case study of Hadeja Jama'ar River Basin 2022 flood disasters. This is why I brought this topic on board, is because of the trauma that we are currently in Nigeria, especially in the northern part, along the Hadeja Jama'ar River Basin. But before I start, the aim of the presentation is to make participants aware of the depth and inaccuracy of Africa regional climate data in terms of validity, reliability, especially of multiple data or regional climate in Africa. This is the aim. At the end of the presentation, everybody is going to see how we are faced with challenges of preserving and managing data in Africa, especially in Nigeria, with more emphasis on northern Nigeria, more particularly on Hadeja Jama'ar River Basin. So the objective of the presentation is to inform participants about the importance of preserving GEO's in situ data in managing climate change associated risk, such as flooding. And the second objective is to tell success stories of sourcing and preserving Africa regional climate data. Example, data on Hadej Jama'ar flood disasters in 2020 and 2022. Now, I have about three steps in data preservation. These three steps are in conformity with GEO's data principles. Number one is data inquiry. If we want to really preserve data, we need to go into an inquiry. Then we need to raise some fundamental questions. And those questions would come from the information that we have that is available in our hands, which means information is key, it's critical. Because for us to get data, there is no way you can even establish any data without having information at stake. Then the second step is data preparation and analysis, as Chris has already alluded to that fact in his introductory remark. So the third aspect, which is the review and taking inventory on each data. Sometimes we need to keep ourselves on track by preparing the data. When we prepare the data, if we are to use it for long-term use, then we need to consistently review it by making corrections, and then we preserve it in the end. So these three steps are very important in terms of data preservation and management. Now the next slide. Now here, this map that you see it comprises lots of data on flood disasters in Hadej Jama'ar in Nigeria, especially in relation to Hadej Jama'ar River Basin. These towns and villages that you see directly on the map of Nigeria, especially the blue signs and the names, especially, let me start from the bottom one: Kwara, Kebbi, Sokoto, Magaria, Dabi Town, Kafin Hausa, Hadeja, Auyo, Birniwa, and Lake Chad. These blue lines and blue colors that you see are climate ravaged areas in terms of flood disasters in Nigeria. In the year 2020, you got this data from Google Earth and Copernicus. This data that we were able to generate in 2020, it had proved to us beyond reasonable doubt that these towns, the blue ones especially, which I'm emphasizing, if care is not taken, are already under climate change red alert. What happened in year 2020, lots of flood destructions, a lot of houses have been ravaged by flood waters, properties lost, and even death. When we analyze this data, that was in 2020, we advised the people of those communities to kindly have an alternative habitat different from the ones that they are currently residing. But some of them, they could not heed our warnings because they thought we are lying. Some are even saying that we were doing it with ill motives. But we were being realistic, telling them to move out of those towns and villages because they are already directly constructed on the riverine areas or the coastal areas of Hadej Jama'ar River Basin. So let me move to the next slide. I will come back to this when I'm going to conclude. Here, in the year 2020, this is Hadej Jama'ar River Basin 2022 flood disasters information. I cannot call it data at this material time. It's information that we have generated. The data, we are going to establish it when we practically verify the number of deaths, number of losses, which we are currently counting. So far the information we have gotten, we have 50 people that were reported death. They died, 50 people died because of the Hadej Jama'ar River Basin flood 2022 disasters. Then over 20,000 hectares of rice farmlands were destroyed by the flood. Then over 300 deaths in Nigeria in year 2020, especially in the months of August and September. Then over 500,000 people lost their houses and properties in Nigeria. So these are a set of information that we have, which could translate into data. We are yet to verify this data because still we are counting the losses, we are counting the number of deaths, and in the end, we would be able to generate a kind of mapped out data, the one that I presented to you in the previous slide. So now, let's come back to the central theme of this discussion, that is data preservation methods. I have about 4 data preservation methods that are in conformity with GEO's data management principles. 1, data preparation and validity. For us to really use data a long term, we need to prepare it. When you prepare the data, you need to validate it. How do you validate it? That is where verification comes in. We cannot use any garbage in, garbage out information or data and take it. We need to verify. Then how do we verify? There are certain sets of principles and the guidelines under GEO, which time will not allow me to really take them one by one. But as we move on, we will be able to explain further to the participants. So the second one is data reliability. Once we hear data reliability, that is integrity test. If we have set of data and we want to see how reliable it is, that is when the integrity test comes in. We need to subject it to different models so that we could verify, and then how integral, how is that data? How sincere are we with those kind of data? Then after ascertaining the integrity of the data, that is where preservation comes in. Then to preserve is to manage and to prepare. To prepare, to coordinate, to manage is to preserve. This is in essence, in a nutshell, what I understand by data preservation under GEO. So to preserve data, after verification, after doing reliability test, integrity test, then you need to preserve it. Then preservation means to prepare, to manage, to forecast, and to coordinate the entire set of data bank that we have at hand. Then the last one, periodic check. Periodic checking of data that would allow us to review the data to make corrections so that we will use it in the future. So I'm moving to the next slide. Then here, like I told you, I'm the kind of person that I always go practical. Under African Climate Change Research Center, when we realized the flood disasters, based on the data that we had in 2020, then we need to do swift intervention under African Climate Change Research Center. So the center, under my own secretaryship, we were able to get a grant. We were able to get flood grant from Border Communities Development Agency in Nigeria. We got 70,000 British pounds grant, which we were able to take care of a climate ravaged village in Silatankarkar local government in Jigawa state. We planted 3 hectares tree shelter belt, because we need to revive the ecosystem. We need to regenerate the ecosystem if at all we want to take care of the climate, to stop seeing these kind of disasters annually. So that was why we had to come up, the African Climate Change Research Center designed this 3 hectares shelter belt and 2 solar powered boreholes that could irrigate the seedlings when we planted. So this is just a 1-year-old project. We finished this in 2021, and this is 2022. As you could see, it's a 3x3 trees shelter belt that already this community that has been ravaged by climate change and other global authorities has been regenerated. And the people are very happy. They didn't witness all the kind of disasters that they have witnessed 2-3 years ago, because we have already came to the rescue under African Climate Change Research Center. So, but under Hadeja Jama'ar River Basin, especially the Hadeja town, Kafin Hausa, Magaria, Debi, and Ringim, those are the kind of places that we need to convert them into sponge cities. Under this scenario, there is the challenge here, we have little political will from the political leaders in Nigeria. They don't have the political will to make it happen. Of course, there is ample funding. And then the World Bank has made a concerted effort under its streaming project, transforming irrigation management in Nigeria along Hadeji Jama'ari. The World Bank has done an amazing job. But because we don't have early warning signs in Nigeria, of course we have, but the people are reluctant to create awareness. As the experts are reluctant to create awareness in the mind of the villagers, in the mind of those people that are living in those areas. So that was why we were overtaken by event in 2022, whereby over 300 people died. Over 20,000 hectares of rice farmland have been completely destroyed by flood waters in 2022. So these are the challenges. And then conclusively, to manage data, there is a need to do the following. One, we have to plan for long-term preservation of data. Then two, curation of data. How do we cure the data? We need to review it, we need to make corrections, and managing it for reprocessing and the future use. Many thanks for giving me the time and the chance to share my ideas. I'm here to listen to your questions, observations, and criticisms. And if I'm able to answer, at least that is halfway to the solution. Thank you so much. Back to the chair.
Thank you so much, Noura. It was really great because you have identified this flood scenario, which is definitely the most frequent disaster based on WMO reports and analyses, and the damages from the floods, which are very difficult to recover. You recover the damages from the wind more easily than from the floods. And then you have showed that it's not the topic of climate change activities is not only to do research, it's to go from research to actions, to mitigate the impacts. And you have shown that this is possible, this is accessible for us, for anyone to find some actions. You have also identified that it's important to raise awareness of the local people, and this is what you have done, but also of the politics, the local politics and the international politics. And this is why we need a lot of these communications here to support that. Any question or comment to Noura's presentation, which I really appreciate again, Noura.
Thank you so much, Mari.
Yes, Bento.
Yes, thank you, Noura, for this very interesting talk and good work that you do. I was wondering, and maybe I didn't capture it well, but how did you, so you talked about preservation of data and information. Did you use that the information that you verified when you were planning your actions, for instance, with planting the trees? What was the link between the data you preserved and how you were able to actually make use of it in a concrete example?
Yeah, actually, yeah, many thanks. This is a very cardinal and important question. It's an excellent question. Actually, the relationship between the flood disasters that we witnessed in northern Nigeria has to do with a lot of desertification and deforestation issues. A lot of people have succeeded in cutting down trees as wood fuel. They have burned the trees, they have cut so many trees. And the way to really mitigate the impact of climate change, to adapt, is to engage in tree planting. Once you plant a tree, if it grows under heavy rainfall, before the rainfall touches the soil, it has to hit the branches of the tree and the leaves so that the pressure will be reduced. That is where tree planting becomes critical. So that is the way you would have a link between desertification or deforestation data that you need to translate it into practical application of knowledge. So that's why when we got the data and we realized that most of the climate disasters that are happening, the flooding, desertification, deforestation, we need to plant more trees, we need to plant, we need to construct more dams, especially along the riverine area. Unfortunately, there is no political will. Of course, we cannot say Nigeria doesn't have money. It has ample money, except that we have bad leaders and corrupt people in the system. I have to tell you this. So that is why the whole entire nation is grappling with lots of issues. So to answer you perfectly, there is already direct connection between desertification and climate change disasters. This is a direct relationship. Then there is an inverse relationship between what we are supposed to do as human beings to salvage the communities and the things that are actually happening, because you cannot stop flood disasters in Nigeria if you don't have early warning system. And unfortunately, we are not like developed nations, whereby if, for instance, Hurricane Katrina is going to happen, the people in Europe would already been informed. They were already been informed. Then they need to evacuate. But in Africa, it's not like that. So these are the challenges that we have. I hope I have answered you.
Thank you.
Thank you, Noura. I have published the result of the polls asking if the catalog of preserved data is meeting the challenges of climate change. Without any surprise, we can see that nobody has voted for the yes. Most of them partly. Of course, we know we have some data which are available. One answered not at all. So we can see that we still have work, and data preservation is a challenge we have to face here. By the way, Noura, I also appreciate that you have distinguished the data verification when the data arrives and the data creation when it is all data that you have to preserve and to keep. So this will be the topic of the next dialogue.
Okay, thank you so much.
So I will take the screen again to share the intro. Oh, I think I did not validate the sharing here. The next speaker will be Sven. Sven Williams is research and development project manager with Vito. And Sven Williams has earned a degree in agricultural engineering, land and forest. So very applied research to agriculture since his start, and is working. I have met Sven in several projects where he helps advance agriculture and the use of new technologies, standards, but also cloud technologies and so on for the benefit of GeoGlam. And he will present preserving in situ for GeoGlam. We have said that in these dialogues, we will always try to have a special focus on in situ, and Sven is bringing that. Thank you, Sven. I let you the floor.
Okay. Thanks. Let me share my screen. And Bente, no problem. About the, Williams is more frequent than Gilliams. So,
it was an autocorrect, I assure you, because I know what your name is.
So I hope you're able to see my screen. This participant thing. Wait.
Yes, we see it.
So GeoGlam, for those who don't know, GeoGlam is a flagship from Geo related to agriculture.
Okay, thanks. Good afternoon, everybody, or maybe good morning, depending on where you are. So my name is Sven Williams. Thanks for the introduction. I work for Vito, independent research company based in Belgium, but I wear several hats. This time I'm going to talk about GeoGlam and the in situ data coordination, because I'm involved in GeoGlam, of course, and part of the in situ data working group. So the background. So how did it start in GeoGlam with in situ data? The how, the why, and the when. In GeoGlam, we're working with several key components to mount focused and effective response for several challenges related towards global agricultural monitoring. And in response to those, we started developing and discussing the essential agricultural variables that provide guidance to support the agricultural state and change monitoring. But of course, we also need tools for that. And next to the tools, we also need data, of course. The figure you see is now an application on climate change and climate adaptation, because GeoGlam is, of course, policy driven, but we can implement it for any kind of applications. So on the one hand side, you have the essential agricultural variables. You have a lot of open source tools that were already developed. One thing you need to know on GeoGlam, there's quite a lot of voluntary contributions. So it's most of the work is coming from projects, different projects supporting GeoGlam, or organizations supporting GeoGlam. So the open source tools to calculate essential agriculture variables were there. But what we saw was a huge lack of in situ data, and that there was a clear need of in situ data creation. On one hand side, you can actually say that the EO data that we need is there, that the computing power is there, but on in situ data there was a huge gap missing, and that's what we are starting to develop at the moment. So let's go with one EAV, the crop type mapping. This is actually started with a project that I'm currently coordinating. That's the World Cereal project, where we actually have to do global crop type mapping, seasonal global crop type mapping at 10-meter scale. Several phases in the project. First phase was on prototyping, developing the system, etc. We're now in phase 2 on the global demonstration. We're actually getting the products out. But the main focus of this talk will be that part in phase 1 where we have building of global reference database. Of course, for the models and the systems that we have in open source, you need in situ data to be able to train. That was a big issue, although we know that there are several organizations, several projects, well, several thousands of projects through time that were collecting data. Getting access to train your models or to train your system to that data was really difficult, and that's where the in situ data coordination from GeoGlam came from. So what were the data requirements? What data did we need? In fact, it was really simple. We just needed data with a location, a crop type, preferably a season, some information on irrigation. That's all we needed. So I would say nothing really confidential, nothing really secretive. I can still understand that in-season data might be a bit difficult, but we needed data from 2017 till now, so that's old data. So there's actually no big deal not to have that open, but it wasn't. We did it. We looked for it, and there was no solution where we had high quality open reference data. So we started a journey. One was on data discovery. There are a number of places where you can start looking. I think the previous speaker also mentioned it, data collection and harmonization. What is the quality of the data I have? What is the information that is in the data? Then for GeoGlam, depending on the EAV, we also have to look at a fitness for use, because for crop yield estimation, you would need different data than for crop type mapping. And even within crop type mapping, you can do different kinds of aggregations of your raw in situ data. So that's another layer you need to do on top of it. And then, of course, data sharing. And it's actually in the data sharing part that we see quite a lot of the activities for the preservation. So at the end of the day, data discovery, we reached out to a number of people that are on this slide. Well, all of them on the slide, but not everybody is on the slide. And what we saw was a huge amount of data, but no single access point or no clear point on how this data was managed, where it was stored, how it was preserved, how long it would be preserved, etc., etc. So all kind of difficulties there. And then you also had some licensing issues. Some of the data was completely public, some of the data was completely private. So also there we have issues. We're still in negotiation with some of the big private organizations where, okay, for validation of the products, we can use their data, but they don't want to share it publicly. So there's also some part of the database that we've developed that is currently hidden from the open part of the database. So at the moment, where are we at? We have around 70 million labels of data. The orange dots you see on the global map are places where we have in situ data. On other areas, we also use data coming from produced maps where we have accuracy figures. But this slide is really focusing on pure in situ data collection. Of course, this is not a one-to-one translation from the data repositories that we had before. There was a huge quality check, and not only on the thematic quality, but also on the spatial accuracy of the data. So there's actually in the database a ranking of in situ data with a quality label. And you can combine thematic and spatial accuracy to come up with an accuracy level, and then you can decide on which level you want to train your next model. If you have a global model, or you want to go very specific, if you want to have more thematic accuracy or spatial accuracy, it's all possible in there. And of course, as you can see, there are also gaps in the database that we still want to fill, that we still want to improve. So if anybody knows very good data sets on agricultural in situ data, please let me know. We're always looking for more. But this is actually really the core of the GeoGlam in situ data workshop, because the basis was a project. Like all of the data that I showed on the previous slides was also coming from projects. The thing that we wanted to avoid within GeoGlam is that this database, when the project ends, also comes to an end. So we really want to preserve that data in the future. And that's where we started the GeoGlam in situ data working group on in situ data, where we reached out to organizations like WFP, FAO, USDA, organizations that already have some kind of repository or some kind of data. And we want to discuss and set up a system that would actually preserve the data for future. And at the moment, this is, well, kind of the structure that we're setting up. This is all still open for discussion, still open for debate. So on the one hand side, you have national organizations or regional organizations that have their repositories. You have already organizations that are within the GeoGlam infrastructure. And then, of course, you need an extra layer on the preservation, on the long-term archive, and then linked to, in our case, then the GeoGlam essential agricultural variables that will flow into a harmonized reference data set that actually users can go through APIs to link with and develop their own methodologies for whatever EAV they want to have. Good thing here is, or the interesting point is, we will be having an in situ data working group workshop on 21st and 22nd of November in Geneva at the GEO offices, coordinated by GeoGlam. And you're all welcome to join us and discuss and see what we can do on preservation. I think in the next presentations, there's also on other people on of GeoGlam and World Seal that will be talking on harmonization and curation of the data, which was really also another huge part of this data set. I think with that was my last slide. So I'll give the floor back to Marie-Françoise.
Thank you very much, Sven. this is a very important, I think, success story, because not all the communities have this already maturity to gather data. As we can see, well, we will see with the next presentation that the harmonization and preservation of the data comes more from the data providers. And here, for the in situ, the activity comes from the users, and the measurement are from the users. And this is why there are so many stakeholders and the data is so much fragmented. So we need some volunteering and some people taking that correctly. And we thank you very much, Sven and Vito, for addressing this with GeoGlam. And so during your talk, we have sent a poll about the data preservation. And do you have a strategy yourself? Do you preserve your data via third parties, or you have no clear strategy on data preservation? And we can see a lot of people do not have a strategy here, and this is probably the first thing to define. You have given some clues in your talk, Sven, saying that this has to come from how you want to use the data for. And you talked about the EAV, that looks to be the driver for GeoGlam. So maybe this could be a topic of discussion in some conference you organize, or maybe in some dialogue about how can the strategy be defined for data preservation for in situ. Bente, you had a question?
Yes, I have a question. Thank you, Sven, for a very good introduction or overview of the work on in situ in GeoGlam. You said that you have there are many different data providers and they're very diverse type of data. And when it comes to the verification and, keeping it verified over some time, have you, so even though you are already a well-established community, the GeoGlam community, but when it comes to verifying the very specific data that requires local knowledge, do you have any examples on how you engage those data providers in keeping, verifying, checking on the data?
Yeah, very good question, Bente, and that's really a difficult one. The thing is that a lot of the data that we're looking at now is historical data, and so the verification part was done on geolocation and thematic accuracy. So we could actually look at 2018, we look for historical data, we look at temporal profiles. Is this agricultural or not? That's difficult, but okay to do. That's not one person who's doing that. That's several people looking at the same spot, looking at time. We also looked at quality checks done by the people in the field. That's done. There's of course obvious mistakes where a point is on a road or point is on a house. That is stuff you can do automatically. The difficult part is that on the agricultural is changing over time. So the cropland class, we set up a system that we can connect with local users, and they can go back to the point and say, okay, this is still cropland or not. The crop type is changing from year to year in most cases. So that's very difficult to keep consistent over time. So the historical data sets, we're quite confident that they're okay. But you can't extrapolate those points in the future. For cropland, you kind of can, because that's kind of stable, but for crop type, you will never be able to preserve them for the future. The good thing is that if you want to train certain models and you want stability over time, the historical data is still very relevant. And combining the historical data with the historical remote sensing data you can train your models based on a robust data set, and that was at the moment completely lacking.
Thank you.
Well, thank you also for emphasizing. We talk of training models. The community puts a lot of hopes in artificial intelligence, but artificial intelligence approach needs training, and it needs calibration, validation, and all that. And all this requires very good in situ preserve data. So if we want to address this big hope of the community, we need to work on these foundations.
Yeah, exactly. And that's also the reason why, because I showed only one of the EAVs, which was crop type mapping. But we want to expand that data set to other EAVs, but you need to start from somewhere, and they all need their specific in situ data sets. But also the historical data set is still relevant, and you really need good quality, verified, good preserved data to be able to develop those models, because otherwise it's rubbish in, rubbish out. I think the previous speaker also mentioned it. If you don't have the correct in situ data, yeah, your models will not be okay, and so the things you're predicting will be completely wrong.
Yeah, we all know when we work in science that the quality of your result and your analysis depend on the quality of the data you assess. Exactly. And most of the work is involved in preparing the data. I would like to, well, if is there any more question for Sven? I don't see any in the chat. I don't see any raised hand. So I will just share my screen to introduce, if I share correctly, Mirko Albani. So we have talked about in situ. The challenge of in situ is this fragmentation and this diversity of data. For satellite, there is not so much fragmentation. There is not such heterogeneity maybe, but there is a major challenge, which is the volume. And Mirko Albani is program manager for the heritage mission as ESA, and he is also a chair for LTDP working group, and is very involved in TIOS, where he chairs the VGIS working group. And we let you the floor, Mirko.
So thanks a lot, Marie-Françoise, and apologies for this, but I really could not find a way to get in. So you just mentioned the fact that we have a lot of data also from space data provider, satellite data provider. So this presentation is my apologies, but I put the presentation together in very quick time. But I'm trying to give an overview on what is happening on the space agency side in terms of preservation of data. Next slide. So at ESA, we have a dedicated program which is covering the preservation, the discovery, the access of heritage data. With heritage data and heritage missions, we refer to missions which are not anymore in operation, but which still provide a wealth of data that are crucial, for example, for climate applications. So all these data are managed together in a program which is run by, which is under the lead of the Earth Observation Directorate, but also run together with other directorates at ESA. So we are also addressing the preservation of science data, so data acquired by satellites looking at our solar system or at the universe and so on. So we have a single program inside ESA addressing in a coordinated manner the preservation of all these assets. In Earth observation, this program is covering more than 150 missions. So not only ESA missions, but also we have missions from third parties, because the agency started acquiring data in the mid-70s and acquiring data from US missions, Japanese missions, and so on over Europe. And these data are made available and disseminated to European users. So we also need to make sure that these data are duly preserved and made accessible to users. Next one. In this program, we have joint activities, so things we do together with the other directorates, but also we have activities which are specific for each directorate, so specifically addressing and focusing on the relevant directorate. And since now on, I will only talk about Earth observation specific activities. So if we go to the next slide. This is an excerpt of Earth observation missions that we are covering. As you see, we have ESA heritage missions, which you might know like ERS and ENVISAT, which were launched, the first one was launched in 1991, so more than 30 years ago. And then we have, as you can see on the right, many other missions whose data are archived at ESA and still made accessible to users. These data are fundamental because basically you can, through the use of this data, show how our planet is changing. So if you want to measure a change with respect to the past, you need to have data from current missions, which are of course crucial for many, many applications. But if you want to see how climate is changing or how something is changing, you need to compare this with the past. And here you have some examples. When you say, for example, in climate, sea level rise, I mean, the sea level is rising and so on, you need to know exactly what was the level 10, 15, 20 years ago. And that's where the heritage data comes to be crucial. Next slide. So this is again an excerpt of all the missions. So I'll skip this one to give some time more to questions and discussion. This is, for example, an example. We made a comparison of data over a Greenland glacier. As you can see, there is a blue line, which is data from an American mission called CSAT. This is SAR data, so Static Aperture Radar data. Thanks, Marie-Françoise, from 1978. And then this was compared with the data from ERS-2 and then from Sentinel-1. And as you can see, the glacier retreated quite a lot in the years. So this is just one example of how this data can be used for climate applications. Next slide. So what are we doing with this data? So we have many activities ongoing at ESA. Bente before asked, do you have a preservation approach and so on? We are plenty of, we have a preservation approach, of course. We have generated together with international partners several guidelines on data preservation, data archiving, data valorization, many different aspects of the data management life cycle. At ESA, what we do, generally, we have 4 main streams of activities for these missions. The first one is coordination and cooperation with others. So we try to do all our activities in cooperation and coordination with other actors, and I'll present a slide later on this. Then we have a stream of activities dealing with the recovery of this information and the preservation and archiving of the data and the information. Recovery means that we still have a lot of data which are, for example, on old media or still to be unfolded inside archives. So we need to make sure that these data are consolidated, recovered, and made accessible to users. And the same for the information which has been generated or which is needed to understand this data. So on the lower part, you need to make sure that all the data we have is properly archived, properly preserved, and properly preserved means that we need every few years to transcribe this data from old technology to new technology, make sure that we have all the metadata in place, that we have all the information. Then we need also to ensure that these data are discoverable and accessible. So to keep the data in a cupboard or in a bank, it's not sufficient. You need to provide access to the users. And this is done through state-of-the-art technologies and tools. So we try as much as possible to follow the same approach which is in place for current missions like Sentinels. So we have a lot of work also in terms of data discovery and access, but also, and this is the tip of the pyramid, let's say, to make sure that these data are properly valorized and reprocessed. For example, Sentinels, newer missions, they always come with new algorithms, new tools, something new. And then what we need to do with the old data is to make sure that they are aligned as much as possible with the new ones. If we want to build a time series, there is some work to be done on the old to try to bring the old as much as possible to the quality and the level of the new ones. And there is, and this is really the most difficult part because there is a huge amount of effort to be done in there. But also, again, we perform usually some reprocessing activities. So we use the algorithms from the newer missions. We bring the algorithm back to the old one. We build again the processor and we reprocess the full data set again so they are as much as possible aligned with the new ones. But also we build new data records. So we try with the old data to build the new time series of innovative products, again, following the examples of the newer missions to provide to the users an increased and enlarged as much as possible amount of data. Next one. So this is a few examples I have just put together. As you can see, this is a picture of the archive, of the media archive we have at Esrin. We still have in these tapes unique data that need to be transcribed. These data were inherited from the past. The main difficulties there in there is to, first of all, find the knowledge about this data. Data from 30 years ago can be difficult today to be understood because the people who was working on this data is not anymore available. They retired, or so one of the difficulties we faced, and so far we have recovered really a huge amount of this old data, is really to have the knowledge of the people, but also the equipment. On the right, you see some very old machinery. This is the machinery we are still using to transcribe some data and recover them. And this, of course, is a manual process which requires a lot of, again, of expertise, but also of effort. In the lower part, there's another recovery action we had some last year where we recovered some negatives of a Landsat data which are unique over Europe, and we are. So besides these recovery activities, we have also. So we can move to the next slide. Next. So these are very quickly some examples of data that we are recovering and making available. So for example, for MERIS, this is an instrument on board of the ESA ENVI satellite. So we have recently completed the 4th reprocessing and quality control activity of the full mission. So what we usually do, we build again the processor, we do a full processing, and then we control and check the quality of the new data sets, and we make this available again to end users. The same happened with MIPAS, which is an atmospheric instrument. And if you go to the next slide, there are a few other examples with the AATSR, which is this instrument which is needed to measure sea surface temperature and land surface temperature, among other things. And we are just finalizing the alignment of this data set to the Sentinel-3 instrument, which means that we will have a complete data set from 1991 to these days, so 30 plus years of coherent and harmonized data, which is again crucial for climate and many other applications. And the next slide shows another example of new data sets that we are building. So there is a huge effort again in also building some fundamental data records. So trying to harmonize the data from different missions, different instruments, to align them, or to provide to the user a way of moving from one data set to the other. And this again is crucial for many different applications. Here you can find a couple of links to 2 fundamental data records that we have started and we are implementing at ESA. The next slide, I think, is the last example, which is EVO-HRR. This mission is a NOAA mission with an instrument flying also now on board of the METOP EUMETSAT satellites. And we recently managed to build an EVO-HRR dataset over Europe from 1981 to 2021. So this is the longest temporal datasets that we have in the world, together with the one available at NOAA in the US. And we managed to do this by implementing a dedicated project, merging datasets from the University of Bern in Switzerland, from the University of Dundee in Scotland, in UK, and from ESA. So we managed to merge all these data sets, and all these data, of course, are completely available free of charge for all the users. So you just go on the ESA website, I open and close brackets, all our data are completely open and free for access to any user. And we are now continuing also to enlarge these data sets, trying to improve also the processing level to go one step further to facilitate life to users. Next slide, and I think I'm close to the end. Of course, we need also to provide access to this data. So we have many instruments at ESA, on the ESA websites, to make this data accessible to end users, again, on an open and free basis. But next slide, please. We are also trying to improve accessibility by making data available on exploitation platforms. So we are trying also to change the paradigm and the approach where the user had to go, take the data, download the data, and work on his own on his platform, especially now with Sentinels, where the volume is so high. It's a huge volume. So we have to prevent or simplify the life to the users. So now we are using platforms where the user can go, find the data, find processing tools, find algorithms, do its processing in the platform itself, and just download the results of the analysis at the end. Next slide. And I think that this is the last one. As I was just mentioning, we are conducting this activity in cooperation with many different actors. The main cooperation, so we are presenting our activities in many international fora, conferences, workshops. We are working also in the standardization domain. So we have, for example, recently put together with NASA and other international colleagues a standard to identify all the information that need to be preserved together with the data. In GEO, we have the Knowledge Hub. We have a lot of focus also on information and not only on data. And this is crucial also for us, especially when you talk and when you use all data. If you do not have the information together with the data are completely unusable. So we are also, we have defined this ISO standard together with NASA and CNES and other space agencies. We are working together with the European Commission in many projects. We have a coordination with the European space agencies in the frame of the what was in the past called LTDP, Long-Term Data Preservation Working Group. This working group is crucial because it was the starting point for many best practices and documents that we have issued. These documents were first issued in the frame of this European group, and then they were extended in the frame of CEOS. CEOS is the Committee on Earth Observation Satellites. It's basically an intergovernmental body where all the members, all the agencies owning Earth observation satellites can participate. And in there is a specific working group which is addressing data preservation aspects, and I'm leading the subgroup dealing with the data preservation and stewardship. And in there we have generated several guidelines, preservation guidelines, dealing with the digital object identifiers and many others, which has been agreed among all the different agencies and which are being now used in Europe, in the US, in Japan, and in many other different space agencies. We have also exported this work to GEO in the past. These guidelines in the past became the GEO Preservation guidelines. Now we have the data management principles. And we have also, as part of the work of the working group, we have in CEOS exported some of the work into the data management principles a few years ago. And we are strictly monitoring what is happening in GEO to make sure that we have alignment with the guidelines we are using, which are specific for space data, with what is happening in GEO. And I think that this is my last slide. So yes, this is my last slide. So again, strong coordination, strong effort in Europe and worldwide to make sure that all the assets we have acquired in the years are duly preserved and made available to end users in the best possible way, both in terms of quality, but also data access instruments, tools, and information and knowledge. So that's all on my side. I don't know if you have any question or comment.
Well, thank you very much, Mirko. Yes, I have some comments and a summary I will do of what has caught my attention. First, that we can understand that it's a huge work because each time you have a new satellite, you have to reassess instrument by instrument and re-homogenize the data to make a series. And this is just amazing. You can do such work. You have mentioned the licenses. It is a focus we try to have also in all the dialogues, saying that ESA is making all that available and open access. This is just great because this is what the community needs for climate change, I think, studies. You have identified that you need a strategy if you want to homogenize. This was, we could foresee that through the previous presentations, but you first need a strategy. What am I going to archive and preserve? And this is great. Then I could notice into the missions that you archive that there are some commercial missions. I could see some demo satellites and so on. So I think that this is a recognition that preserving such heritage data is a skill, and companies trust you to do that for them. So this is just very interesting.
Yeah, let me jump in on this point. This is at ESA, we have another program which is called EarthNet, which is a program through which we can take data from commercial missions and make this data available to scientists, open and free, again. So our policy is really to make all the data available on an open and free basis. Of course, with commercial missions, this is not the case. So sometimes we put together arrangements with some commercial companies, some commercial missions to make this data available to end users. So in our archive, we have also this data that we have acquired in the past. The preservation of commercial data is an issue today because, you know, commercial operators, they have to sell the data, and all data are not so important in the sense of selling the data. They are fundamental for research, for scientists, but it's difficult to sell them. So what usually happens is that they do not properly perform preservation actions. So they leave the data where they are on the old tapes. Then if someone asks for the data, they go there, they check. If the data is still readable, fine, they sell it. Otherwise, it's gone. And this is a major issue. So today, what we are trying also to do in some cases is to get the full archives of missions. So we are starting, for example, a project with a German company who has a full archive of Indian remote sensing satellites mission over Europe. These data are going to be lost. So when there is a situation where the data are going to be lost, then there is something we have agreed with the other agencies in CEOS that the owner of the data can make a purge alert saying, hey guys, I'm losing this data, I cannot maintain them anymore. And then if someone else is interested, they can take over, understand the data, and make this available to users. And we are doing SIM in some cases, which I think is important for humankind, I would say.
This is why in the previous questions I had put, or I forgot to publish the poll here. I had put the question: do you have a strategy to host your data through third parties? Because I think that for heritage data, for historical data, this question has to be identified. In the strategy is how long do I keep the data myself, and what do I do if I don't want to keep it anymore, or I cannot do that because it has a cost. We have seen through your presentation and through the one from Chris that migrating data from one support, physical support, to another, it's an endless work.
Yes, and it costs a lot of money.
And it costs a lot of money because there is a lot of manual activity for that.
Well, at the beginning, there was some manual activity. Now, of course, we have migrated all the data that we have into robotic tape libraries. So all this is done now automatically. So we do not have any more the manual intervention. We just buy the new archive, the new technology, and we do the migration. So it's more automated. But still, we found in different places all the data on old media, and that one has to be done manually. But the strategy is crucial, Marie-Françoise. We have also, together with the other agencies, developed what we call a workflow. So all a series of steps that you need to do since the beginning. The first thing is, okay, I have this data. What do I do with this data? So you generally do an appraisal. What is this data useful for? Who is the user community? So the designated community. What are their needs? And so what is the action I should do on this data? And then you start also basing on the resources that you have to plan some consolidation activities, then some reprocessing eventually, some quality check, then you have to archive them, then you have to make them accessible. And then when you end up the chain, there is a sort of loop, because then you start again, because a new mission is coming, and then you say, oh, there's a new mission, new algorithm. So should I touch again what I just finished to do? Yes, okay, and then you start again from scratch. So not from scratch, but at least you have to do some improvement loops. As you saw before, I was showing the fourth reprocessing of an instrument, and this might become the fifth one in the years. So without a strategy and without a clear guidelines on how to implement the strategy, you will not be able to preserve the data in the proper way.
Bente, you had raised your hand. I apologize. We are going a bit later. I think, Mirko, you were busy also. Let's try to speed up. But
very quickly, Mirko, thank you for this very nice overview that really convinced us that this is resource demanding. And what I know that ESA is funded by the member countries, and you have different programs that each member country, contribute to. So one question is, how is this funding model to secure the continuous resources to maintain this preservation? That's one question. And the other part is, I know from sea level, just satellite measuring sea level, the altimetries, that you have the issue of resolution, for instance, and how do you make long time series in different missions? that is that's even a scientific project to make this, align this different missions. Do you have a special program for this kind of alignment that is not necessary, that requires actually science?
Thanks for the questions. So the first question, yes, okay, how to explain? At ESA, we have mandatory activities and mandatory programs and optional programs. So a mandatory program is something that you have as a member state to, you are subscribed to this mandatory program by default, let's say. And then you have optional programs that we present when we have a ministerial. So we present the package, for example, in Earth observation, dealing with Copernicus or with future EO and so on. So the optional programs usually address new missions, whilst we manage to have all these heritage missions as part of the mandatory activities. So we have, in theory, and I have to say it's tough, because every 3 years it's a battle, because in the mandatory activity at ESA we have apples and pears, and so when you have to compare apples with pears, I have to tell you it's always a fight. It's more important to have a technology development or to have education or to preserve data. For me, to preserve data, for the education folks is education. So, heritage space activities are part of the ESA mandatory activities. So it's a mandate of the agency. And the nice thing is that we are managing to do this together with also the science people, the human and robotic explorations, the ops people. So all the heritage data acquired by past ESA missions, we are preserving them and making accessible. For the valorization, for the alignment and so on, we are doing these activities as part of the same program, because the program is covering all the old missions. So whatever activity I do on ERS, on MVSAT, I have to fund this with this budget. That's why we have the pyramid. So yes. First I need to have the basement. So I need to make sure that everything is archived, is there, and it's not lost. Then I need to make it accessible. Then if I still have some funding, I can try to look at sentinels, harmonized, aligned, and do scientific project, because what you just said is crucial. I'm doing, for example, the EVO-HRR activity with scientists, with the University of Bern. They know how they want the data. They have also to align with other scientists in Europe, because they are not the only ones. So I asked them at the beginning to collect the requirements from the scientific community, and what better than a scientist defining the format and then going and doing the reprocessing. So we are doing everything as part of this program, of course, trying to optimize the resources we have with what we can achieve.
Chris, you had a question?
Not a question, just a additional comment here. So regarding archiving and also archiving is so sensitive in the sense of techniques and data formats. So and we did also a lot of experiments here. So and depends on the archive format. If you are using integer or float numbers, yeah. Also regarding to the cost and space you need, yeah. So. With one project, we made the same, or we compared the same scene, the same algorithm, and so on, but we get different, significant differences, yeah, out of them. And it's really challenging here. That's why I think it's important, and what you said, Mirko. So it's really important to have a data mination of a planning and a strategy here.
Yeah.
Noura, you have raised your hand.
Many thanks for your elaborate presentation. I really enjoyed it, especially the slide that you have shown us when making reference to the past data to understand the present, to safeguard the future. That is sustainability aspect. But in your data, when you were making reference to green Iceland melting, you have already talked about the Sentinel data of 1978, which you made reference to. So I'm wondering, in terms of updating your data, there is already a crisis that we have in terms of climate change, whereby we have 2 glaciers that already melted at the Antarctica. And this has already risen the sea level by 0.03%. So how do you really harmonize your past data with the present in terms of validation and then updating of the data to understand the present, because currently we have a situation here, sir.
Well, let's say that in terms of validation, harmonization, if I correctly catch your question, we try again to build a time series. So in this case, the example that I showed you on the glaciers is not exactly a time series, because we have some data in L band, which is the CSAT SAR, and then some data in C band. So with the old data, we try to do what we can, because it's old is the only thing we have. So we try to harmonize this as much as possible. For the newer data, what we try to do in terms of validation, there are different algorithms, different ways of harmonizing data, and different approach. It depends on the instruments, it depends on the mission, it depends on the project. So we can have different examples made available. I do not have them now, but I can touch base offline with you if you want, and we can further discuss this. So we try to start with the instruments we have. So the first approach is try to have a continuity with Sentinels. Sentinels are the present and the future. So several of the Sentinels instruments have been inherited by ERS and ENVISAT instruments. So the SAR, the altimeter, the scatterometer, and the MARIS, the OLCI, and so on. So we have several of them. So of course, Sentinels 1 are better than the old one, because the technology has evolved and we have better instruments. So we try to go back to the old ones and do our best to not to have the same level, because this is probably impossible. For example, for SAR, we have a different resolution, different accuracy. This is something we cannot achieve with the old satellites, but at least we can try to harmonize, to align, or to come as close as possible to the new ones, so there is a way of comparing. And then some other work we are doing is trying to go, I don't know if you heard about analysis-ready data. It's something that is very much being discussed in CEOS. So we are trying to process all the data to level 2, so to a level which is as close as possible to the user needs, in a homogeneous way between different instruments on grids, so that you can build data cubes, for example. So you can have on a place different images, different parameters that you can extract without the need for you as a user to do some processing, some alignment, and some activities. So we try to do as much as possible this pre-processing and this processing at the space agency side, and make these products available to the users in a way that can be readily used by scientists and then users.
Thank you very much.
Well, I'm super sorry to interrupt this discussion, because we have passed the deadline of 20 minutes and we are not supposed to. We did not have as many speakers as before, but what I can see is that passionate people are making the topic very fascinating too, and fascinating. So next week is data curation, and it is a very linked topic. So maybe we will invite some of you to follow up the discussion, because, well, when I say some of you, some of the speakers, maybe we will reinvite some of the speakers, because it is linked. And I think it's interesting to see how the topic is addressed for in situ, for satellite. And if I have a regret here, is not to have invited people working on numerical model, because the data preservation is also handled in a different way. Maybe we will try to catch up on that next week. Well,
pictures.
Thank you very much.
Pictures.
Yes, if you can put your video on, then Bente makes pictures of the brave attendees who stayed until the end. Thank you very much.
Yeah, thank you. Yolanda, are you shy? Yolanda is your colleague, Mirko, right?
Yes.
Yes. Well, I'm taking pictures. Yeah.
Sorry, I'm here. Yeah. No shy. It's
no
really
shy.
interesting. No, really interesting. A lot of interesting topic and words that I put on my. But a question: the recording is available?
It will be available.
It will be.
Oh, fantastic!
Yeah.
Thank you. Yeah.
Thank you.
Really useful.
Thank you very much.
Thank you very much. See you hopefully in
Thank
the
you.
next.
Bye-bye.
Yeah.
Thank you.
Bye-bye. Thank you.
Goodbye. Bye. Have a good day.
Bye.